Hello, my name is Sophia Krause-Levy, and today I am going to be discussing the topic of exploring the link between prerequisites and performance in advanced data structures. This work was conducted by myself and my colleagues at UC San Diego. Now, we've all had that struggling student where we aren't sure how they got into our class. You may be wondering, are students coming into my course with insufficient prerequisite knowledge? The answer is yes. You are correct. Students are coming in with insufficient prerequisite knowledge. A previous study by my research group used a pre-term survey in an advanced data structures course to test students' prerequisite knowledge upon entry to the course. The survey consisted of 15 questions on prerequisite content and was given on the first day of instruction. If you look at the bar graph on the left-hand side, you can see the x-axis represents the score on the survey students received, and the y-axis represents the number of students that received that score. No student received a perfect score. If you look at the area outlined by the box in red, you can see 1/3 of the students answered less than half of the questions correctly. These students were judged to have poor prerequisite knowledge. It was also found that prerequisite knowledge correlated with performance on the final exam. Now that we know students are coming into courses with insufficient prerequisite knowledge, a new question arises. Why is there a mismatch between our expectations of student preparation and their actual abilities? Now, before I answer this question, I'm going to give you some background on our study. Our study took place in an advanced data structures course. In fact, the same course offering as the previous study. If you look at the left-hand side, you can see the components of this course, and on the right-hand side is the grading breakdown for those components. This course consisted of reading, participation, programming assignments, in-class quizzes, an in-class midterm, and an in-class final exam. Now, the main prerequisite chain for the Advanced Data Structures course includes CS1, CS2, Computer Organization, Discrete Math, and Advanced Discrete Math. The reason I say main prerequisite chain is these are the prerequisites that are required for a computer science major to take before the Advanced Data Structures course. There are other courses that can count as these prerequisites and allow students to take the Advanced Data Structures course. Now, going back to the survey that I mentioned earlier, this survey included 15 questions, all on the prerequisites that I just showed you. These questions came from validated assessments, and where validated assessments were not available, instructors were asked for questions that represented the material covered in their courses, and these courses were prerequisites of the Advanced Data Structures course. The population of the Advanced Data Structures course included 375 students. Of those students, 202 were included in our study. We included students that had taken the pre-term survey, the final exam, and their prerequisites at our university. The reason for this last part is that our research questions depend on prerequisite course grades and the ability to compare grades between course offerings. We also excluded students who took the course Pass No Pass. Now, for these 202 students, we collected various data measurements. We collected the pre-term survey scores, final exam scores, and students' previous course grades. This included all of the grades they had received at our university. Once we received these course grades, we quickly realized that we needed to normalize the grades for variation in grading. An A in one course is very different from an A in another course. So if different instructors are teaching the same course, an instructor is teaching a course during different course offerings, or just two completely different courses, can have a lot of variation in how they were grading and the grades that were received. An example is these two students, the student on the left in green and the student on the right in blue. The student on the left in green received an A, but so did 34 other people in that course. For the student in blue, there were only 4 other students that received an A, showing that this student was exemplary by just being one of a few students to receive that grade. Now, in order to normalize for grades in variation in grading, we scraped our online evaluation system for course grade distributions and normalized this data via z-score. From this data, after it was normalized, we created 3 student performance measurements. These included overall GPA, prerequisite GPA, and non-prerequisite GPA. For those of you that aren't familiar with the term GPA, it stands for grade point average, and it is typically the average grade a student has received across all of the courses they've taken at university. We are going to call this overall GPA. Next, we have prerequisite GPA, and this is the average grade a student received in all of their direct prerequisites of the Advanced Data Structures course. In cases where a student took more than one course that could count for a prerequisite of the Advanced Data Structures course, the course grade for the course that was most recently taken was used, as it is most representative of the knowledge when entering the course, the Advanced Data Structures course. Our final measurement was non-prerequisite GPA. This is really a non-prerequisite, non-CS GPA. This represents the average grade of all of the courses a student has taken at our university and excludes any direct prerequisite of the Advanced Data Structures course and any computer science course a student may have taken. The reason computer science courses are excluded from the non-prerequisite GPA is to lessen contributions related to special enthusiasm for CS or prior CS knowledge that may implicitly overlap with the prerequisites. So now that I've given you some background, it's time to return to our question. Why is there a mismatch between our expectation of students' abilities and preparation and their actual abilities? Now, before we go into answering this question, we need to answer the baseline question of, do students learn in prerequisites? This may be an assumption that we have, but we need to see if it's true before we move on and ask what else might be causing this mismatch. We found that students do learn in prerequisites. Prerequisites do matter to student success. To determine this, we looked at the correlation between survey score and prerequisite GPA. We found that this correlation was statistically significant, showing that prerequisites do matter to student success. Now we know that this probably isn't the issue, and it's time for us to try to understand what is causing this mismatch. We first looked at time. Does prerequisite learning fade with time? Does it matter if a student took all of their prerequisites 1 term ago versus 1 year ago? We aren't sure. There's been a lot of research that has shown that learning does fade with time, but we found no support for this. If you want to learn more about our research for this area, please read the paper. So if it isn't that prerequisite learning is fading with time, what could it be? What about taking an alternative prerequisite? So taking a discrete mathematics course in the math department instead of in the computer science department to fulfill that prerequisite for the Advanced Data Structures course. We aren't sure. We didn't see anything suggesting this was true, but it's important to remember that we didn't include students that took their prerequisites at another university and transferred those credits. So we aren't sure why this mismatch exists, but it does bring about another important question. If students are coming in underprepared, then how is it they're succeeding in the course? This led to our next research question. Are other factors than prerequisite preparation influencing student success in the course? The answer is yes, and this will be the focus of the rest of my talk. So what are possible other factors for success? What do we mean by other factors? I'm going to bring back this graph that I showed you earlier. Now, some of you may have noticed before, but approximately 50% of the Advanced Data Structures course allows for collaboration or awards effort, and this is typical of the courses in our CSE department. We're not sure specifically what these other factors for success may be, but we were thinking things such as collaboration, effort, study skills, and participation. So we know prerequisite grades have a strong correlation to prerequisite knowledge on entry to the course, but what about other factors? To understand this, we looked at the correlation between non-prerequisite GPA and survey score, and we found that this correlation was statistically significant. both the prerequisite and the non-prerequisite GPAs are statistically correlated with performance on the survey. So we know that non-prerequisite GPA is also predictive of prerequisite knowledge. But the survey score was in class and didn't allow for these other factors. So the next question is there a statistically significant difference in these two correlations to the survey score? To answer this question, we used Williams' test for overlapping dependent populations to determine if the correlations were in fact statistically different. And we found yes, they were. So prerequisite GPA is more predictive of prerequisite knowledge upon entry to the course than non-prerequisite GPA. Next, we looked at final exam and course grade. If non-prerequisite GPA and these other factors are correlated with the survey, then we would expect them to also be correlated with the final exam and the course grade. Though the final exam doesn't allow for these other factors, whereas the course grade does, so we would expect it to be most correlated with the course grade. For this, we looked at the correlations between prerequisite GPA, non-prerequisite GPA, and survey score to the final exam and the course grade. For the final exam, we found that all of these measurements were correlated statistically significantly to the final exam. So what about course grade? We would expect that non-prerequisite GPA is even more correlated with the course grade, and that there's less of a difference between the prerequisite GPA and the non-prerequisite GPA correlations to the course grade, as it allows for these other factors. And that is exactly what we saw. So non-prerequisite GPA is predictive of student success for the course grade and for the final exam. Now we'll go back to a similar question to what we had before, using Williams' test. Is the non-prerequisite GPA more statistically correlated with either of these two measurements than the prerequisite GPA? We would expect that the prerequisite GPA is more statistically correlated with the final exam than the non-prerequisite GPA, as the final exam does not allow for these other factors. Whereas for the course grade, we would expect that the prerequisite GPA and non-prerequisite GPA are similarly correlated to the course grade. We found that there is a statistically significant difference between the prerequisite and non-prerequisite GPAs to the final exam, the prerequisite GPA being more predictive. For the course grade, there was no statistically significant difference, so both the non-prerequisite and the prerequisite GPA are similarly correlated with performance in the course. So now the question becomes, what is the relative importance of other factors? We know that prerequisite knowledge helps with student success, and so does other factors, but how do these create student success? What are their relative importance to the advanced data structure's student success? To answer this question, we performed multiple linear regression and looked at the R-squared difference. R-squared difference shows the relevance of a variable and how it affects the R-squared value. So for example, say we were performing multiple linear regression to see the relative importance of factors in predicting the final exam. In this case, prerequisite GPA, non-prerequisite GPA, and preterm survey score. If we want to know the relative importance of prerequisite GPA, we would first perform the multiple linear regression with prerequisite GPA included as an independent variable, and then performing it again, excluding prerequisite GPA. From this, we can look at the R-squared values and look at the difference between these two different multiple linear regressions to see if it was statistically significant. We first looked at the final exam. Here we found that only the prerequisite GPA was a substantial predictor and was statistically significant. We would expect for the course grade, we would see that the non-prerequisite GPA is also a predictor of the course grade, and in this case we saw that. The R-squared diffs were both statistically significant for prerequisite GPA and non-prerequisite GPA. This shows that other factors do matter. It supports the hypothesis that other factors are influencing student success. So what are these other factors? It's important to remember grades and courses may reflect a number of elements, including actual knowledge of course content, but also things such as study skills associated with success in that course, motivation to study in that field, prior experience and knowledge in that field, diligence as a student, and other skills such as spatial reasoning, critical thinking skills, and mathematical reasoning. Future work should look to explore which of these factors are most important and work to help distinguish between the correlations we've found here and the causation of student success. Now, our study does have some limitations to generalizability beyond the Advanced Data Structures course. It's important to remember that this occurred in only an Advanced Data Structures course, in only one section of this course, at one institution. Also, our preterm survey is short and not validated. In summary, we found that student success in subsequent courses is correlated with their performance on prerequisite courses. Also, we found that grades in courses that are not required and are in other fields than computing are also correlated to student success. This supports the hypothesis that there are other factors contributing to final grades in classes other than prerequisite preparation, and that these are influencing student success. This is the end of my talk. Thank you for listening. If you have any questions or comments, please put them in the comments section below.